Welcome to this comprehensive guide for C# beginners. We'll explore creating a reusable data persistence layer, a fundamental concept for robust software. This layer is crucial for managing how your application interacts with data storage efficiently. A data persistence layer is crucial in software architecture. It manages data storage and retrieval from mediums like databases or file systems. This layer ensures your application's data is safely stored and accessible, bridging application logic and storage mechanisms. One primary benefit is separation of concerns. This ensures business logic remains independent of data access details. This clean division makes your code easier to understand, modify, and test, improving overall software quality and maintainability. This also enhances reusability. The same data access logic can be applied across various parts of an application or different projects without duplicating code. This promotes consistency and efficiency, allowing a single method to serve multiple components. Improved testability is another key advantage. A distinct persistence layer enables easier unit testing of business logic with mock data sources. This allows simulating data scenarios and thoroughly testing application behavior without a live database, making tests faster and more reliable. Furthermore, it offers increased flexibility. Changes in underlying data storage technology, like migrating from SQL to NoSQL, can be facilitated without impacting the application's core. This adaptability future-proofs your application against technological shifts, ensuring long-term viability. Finally, better maintainability is achieved by centralizing data access code. This makes updates, bug fixes, and debugging more straightforward. Consolidating data operations simplifies the development lifecycle, reducing time and effort for ongoing maintenance and support. The generic repository pattern is an abstraction layer over data sources. It provides a common, type-agnostic interface for CRUD operations. This pattern effectively hides underlying data storage complexities from your application's business logic, promoting cleaner and more modular code. CRUD stands for Create, Read, Update, and Delete. These are the fundamental operations for managing data within any persistent storage system. Create adds new data, read retrieves, update modifies, and delete removes records. Mastering these operations is key to effective data management. This pattern makes the persistence layer highly reusable and maintainable across your projects. You define a single set of data access methods for any entity type, reducing code duplication and ensuring consistency. This approach saves development time and simplifies code-based management. Let's begin by setting up a simple C# project in Visual Studio. This initial setup provides the foundational structure to build and test our reusable data persistence layer. We'll use a console application for clarity, focusing on back-end logic without UI complexities. First, create a new console app project in Visual Studio. Select the console app template for C# and name it Persistence Layer Demo. This project name clearly indicates its purpose. Choose a suitable location for saving your project files, as this is our starting point. Next, we'll define a basic model, a product class, to represent the data we'll be working with. This plain C# class will serve as our primary entity, encapsulating the properties of a product that we want to store, retrieve, update, and delete using our persistence layer. This product class will have properties for ID, name, and price. The ID property uniquely identifies each product. The name stores its descriptive name. The price accurately represents its cost. These properties are fundamental for any product entity. Now, let's create the core of our persistence layer, the generic iRepository T interface. An interface defines a contract, specifying methods any implementing class must provide. The T signifies a generic interface, making our repository flexible and reusable for various entity types. This interface will define our standard CRUD methods: add for creating, get by ID for retrieving, get all for fetching all, update for modifying, and delete for removing entities. These methods ensure a consistent API for data operations and form the backbone of our data access layer. For demonstration purposes, we'll implement this interface with a simple in-memory repository T class. This in-memory implementation is ideal for illustrating the repository pattern's functionality without a full database setup. It allows us to focus purely on the repository logic and data interaction. This in-memory repository will use a list, T, to simulate data storage without a real database. This list, T, holds entities in memory for execution, acting as a temporary, lightweight database. This approach allows us to test our CRUD operations quickly and efficiently. The add method simply adds an entity to our internal list. It takes an entity of type T and appends it to our underscore data list. This simulates creating a new record in a database, making the entity available for subsequent operations within our in-memory store. For get by ID, we'll use LINQ's first or default to retrieve an entity by its ID. This efficiently searches our underscore data list for an entity whose ID matches the parameter. First or default returns the first match or a default value if no match is found. The getAll method returns all entities currently stored in our list. It returns an IEnumerable, T, a flexible collection type, allowing us to iterate over all products or other entities. This method is useful for displaying all available data from our in-memory repository. To update an entity, we find the existing one by ID, remove it, and then add the new, updated entity. This effectively replaces the old version with the new one, reflecting any changes made to its properties, such as a price adjustment. This ensures data consistency. Finally, the delete method removes an entity from the list based on its ID. It first locates the entity by its unique ID. Once identified, it is removed from the underscore data list. This operation simulates deleting a record from a database, ensuring the specified entity is no longer available. Now, let's see how to use this in-memory repository product in our program.cs file. This demonstrates the practical application of our persistence layer. We'll instantiate the repository and perform various CRUD operations to showcase its functionality within our console application. We'll start by adding a new product, for example, a laptop with an ID of 1 and a price of $1,200. We'll instantiate a new product object and use our product repository to add this product. This simulates adding a new item to our inventory, making it the first record in our system. Next, we can retrieve all products to verify our addition. We'll call the getAll method on our product repository to retrieve all stored products. We can then iterate and print each product's details, confirming our newly added laptop is present and correctly stored. Let's update the price of our laptop product to $1,150. We'll first retrieve the laptop using its ID. Once we have the object, we'll modify its price property. Finally, we'll call the update method on our product repository to persist this change in our in-memory store. Finally, we'll demonstrate deleting the product by its ID. We will call the delete method on our product repository, passing in the ID of the laptop product. This action removes the laptop entity from our in-memory list. If we call getAll again, the laptop product will no longer appear. This showcases the clean and reusable nature of the generic repository pattern. Our application logic interacts with the iRepository product interface, unaware of implementation details. This abstraction is key to building flexible and maintainable applications, allowing easy swapping of data storage mechanisms. In summary, a well-defined persistence layer with a generic repository pattern offers significant benefits for any C# application. It promotes good software design principles, leading to robust, adaptable, and easier-to-manage systems. This architectural approach is crucial for long-term project success. It abstracts data access, making your application more modular and easier to manage. This provides a simplified, consistent interface for your business logic. Components interact with data without knowing storage specifics, resulting in a system easier to manage, scale, and evolve over time. For next steps, consider implementing this pattern with Entity Framework Core. EF Core is a powerful, widely adopted object relational mapper in the .NET ecosystem. It simplifies database interactions significantly, providing a robust framework for connecting your C# objects to a relational database for real-world applications. EF Core is a lightweight, extensible, open-source, and cross-platform object relational mapper for .NET. Lightweight means a small footprint. Extensibility allows custom behaviors. Open source benefits from community contributions, and cross-platform ensures versatility across Windows, Mac OS, and Linux. It allows developers to interact with databases using .NET objects, significantly reducing boilerplate data access code. This object-oriented approach accelerates development and makes your code cleaner and more readable. YEF Core maps C# classes directly to database tables, simplifying data manipulation. YEF Core operates with entity classes, like our product model, and a DB context object. Entity classes represent database tables. The DB context acts as a database session, allowing you to query, track changes, and save data. It's the central point for all your database interactions. The DB context contains DB set, entity, properties for querying and saving data. Each DB set represents a collection of entities mapping to a database table. These DB set properties are your primary entry points for querying data using LINQ and saving changes. You configure DB context using options builders. For example, options builder that use SQL Server for SQL Server. This allows specifying the database provider and connection string. YEF Core supports many providers, like Use SQLite or Use in-memory database for testing, offering great flexibility in database choice. Data is queried using LINQ, like DB, products, or .to-list async. This allows writing C# queries translated into SQL by YEF Core. LINQ provides a powerful, type-safe way to interact with your database, retrieving specific data efficiently. Saving data involves adding entities and then calling save changes async. First, add new entities or modify existing ones. Then, save changes async detects all changes and persists them to the database in a single transaction. This ensures data integrity and consistency. The iRepository T interface can be seamlessly implemented using YEF Core. Your YEF Core repository T implementation interacts directly with the DB context. This allows swapping data sources from an in-memory list to a real database with minimal changes to your application's business logic, thanks to the interface abstraction. This means you can switch from an in-memory list to a real database without altering your application's business logic. Develop and test using an in-memory list, then effortlessly switch to a robust database like SQL Server for deployment. This demonstrates the true power of the generic repository pattern. For production applications, remember to consider database understanding, testing, performance, security, logging, and migration strategies. These critical aspects ensure a robust, stable, and scalable application. Thorough planning is vital for long-term success and maintainability of your software system. Thank you for watching this tutorial on creating a reusable data persistence layer in C#. We hope you now understand the generic repository pattern, its benefits, and how it can be implemented with Entity Framework Core. Keep practicing these concepts to build robust and maintainable C# applications.